Good morning, parents, teachers, and learners. Welcome back to our Mathematics 8 Valenzuela Facebook Live. We are now on quarter 4, week 7, wherein we will discuss counting the number of occurrences of an outcome in an experiment. Let me present to you our objective for today. At the end of the discussion, you should be able to count the number of occurrences of an outcome in an experiment with the use of table, tree diagram, systematic listing, and fundamental counting principle. Please be ready with your ADM or modules and turn it on page 22 in mathematics section. Make sure that your pen and paper are with you for solving and taking down notes purposes. Students, this is my friend Cassie. Cassie has been craving for her favorite meals from a certain fast food restaurant. Luckily, it is offering al fresco that week. However, she needs to make a reservation before she can go there and have a meal. Before ordering, she needs to unlock the word that will serve as her pass. And to make this possible, she needs to determine the word of the day. To find the word, we need to help her complete the activity. This activity is entitled Unscramble the Jumbled. You need to arrange the jumbled letters to determine the correct answer within 10 seconds. Each correct answer corresponds to a letter that will help Cassie to guess the word of the day. Are you ready? For question number 1, it is any activity with an observable result. Your 10 seconds starts now. The correct word is experiment. Now, we have our first letter C. Excellent. For question number 2, it is the result of your experiment. 10 seconds, go. If you answered outcome, then you are correct. With this, we obtain the next letter O. For question number 3, the answer is composed of 2 words. It is the set of all possible outcomes. Your timer starts now. The correct answer is sample space. With that, we now have our third letter U. Good job! For question number 4, it is a subset of sample space. 10 seconds. If you answered event, that is correct. That means we have now N as the fourth letter. Next is question number 5. It is an arrangement of data in rows and columns or possibly in a more complex structure. 10 seconds to key in your answer. Go! The answer is table. Great! We now have letter T and 3 more letters to go. For question number 6, it is a special type of graph used to determine the outcomes of an experiment. It consists of branches that are labeled with either frequencies or probabilities. It is also composed of 2 words. Timer starts now. If you answered tree diagram, that is right. The letter that corresponds to it is I. Question number 7. It consists of 2 words. It is a method which the outcomes for an event can be listed in an organized way to make sure that none of the possible outcomes is missed out. You have 10 seconds to answer. Go! Systematic listing is the correct answer. That's great, student. We now have N as the 7th letter. And to find the last letter that will complete the word of the day, let us answer question number 8. It is a central or primary rule or principle on which something is based. 10 seconds, go! That is correct. The word is fundamental. And the last letter of the word is G. Therefore, the word of the day is counting. Good job, students! Now that Cassie already knows the word of the day, she can order a meal from her favorite fast food restaurant. The fast food restaurant offers a meal special, 199 pesos, for a combination of a drink, a sandwich, and a dessert. The choices are, for drink, she can choose from soda, fruit juice, and chocolate shake. For sandwich, the choices are grilled chicken, cheese and ham, fish fillet. And for the dessert, she can have either chocolate chip cookie or banana muffin. The question is, how many meal combos or meal combinations are possible to order? How do we solve this kind of word problems? How do we determine the number of possible ways or possible outcomes or possible combinations we can arrange things like in the previously provided problem? To answer the question, let us discuss random experiment and the ways on how to count the number of occurrences of an outcome in an experiment. A random experiment is an experiment, trial, or observation that can be repeated numerous times under the same conditions. The outcome of an individual random experiment must be independent and identically distributed. It must in no way be affected by any previous outcome and cannot be predicted with certainty. Here are some examples of a random experiment. The tossing of a coin. The experiment can yield two possible outcomes, a head or a tail. The roll of a die. The experiment can yield 6 possible outcomes, and these outcomes are the numbers 1 to 6 as the die faces are labeled. The selection of numbered ball 1 to 50 in an urn. The experiment can yield 50 possible outcomes. Percentage of cost dropped due to errors over a particular time. The experiment can yield several different outcomes in the region 0 to 100%. The time difference between two messages arriving at a message center. This experiment can yield any number of possible outcomes. Let us try to count the number of occurrences of an outcome in an experiment. Example number 1. List all the possible outcomes for the experiment of tossing a 1 peso coin and 5 peso coin. The possible outcomes for the 1 peso coin are a head or a tail. The possible outcomes for the 5 peso coin are a head or a tail. The list of all possible outcomes for this experiment can be shown using a table. A table is an arrangement of data in rows and columns or possibly in a more complex structure. Pairing the choices from 1 peso coin and 5 peso coin, we can obtain head-head, tail-head, head-tail, and tail-tail. The experiment has 4 possible outcomes. Let us now use a tree diagram. It is a special type of graph used to determine the outcomes of an experiment. It consists of branches that are labeled with either frequencies or probabilities. We have the choices head and tail from the 1 peso coin. Each will be paired to the choices of 5 peso coin, head and tail. The same result is obtained by using a tree diagram. Systematic listing is a method which the outcomes for an event can be listed in an organized way. With this, we still attain the same sample space with a total of 4 possible outcomes. For example number 2, if a 1 peso coin is tossed and a standard 6-sided die is rolled, how many outcomes are there? List down all these outcomes using a tree diagram, a table, and systematic listing. The possible outcomes for the coin, head and tail. The possible outcomes for the die, numbers 1, 2, 3, 4, 5, and 6. Using a tree diagram, we pair the choices from 1 peso coin, the head and the tail, to each of the choices from the 6-sided die. So how many outcomes did we get? That is right. There are 12 possible outcomes using the tree diagram. What about using a table? Could we get the same answer? Let us find out. Using a table, we obtain head and 1, head and 2, head and 3, head and 4, head and 5, head and 6, tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, and tail and 6. A total of 12 possible outcomes. Using systematic listing, we obtain the same set of outcomes. So there are 12 possible outcomes in doing this experiment. For example, number 3, Lily is pondering her outfit options. She owns blouses in the use of red, purple, and blue, as well as black and white jeans. How many outfits does Lily have to choose from, assuming she only wears one shirt and one pair of pants? There are 3 choices for the blouse, colors red, purple, and blue, and 2 choices for her pants, colors black and white. Using tree diagram, let us pair each color of the blouse to each colors of the pants. How many outfits are there in total? Very good. Lily can have 6 outfits out of the 3 colors of blouses and 2 colors of pants. Using a table, as we pair the choices for the blouse and the choices of the pants, we still obtain the 6 outfits. And lastly, listing the outcomes systematically, we come down with a sample space consisting of red blouse and black pants, red blouse and white pants, purple blouse and black pants, purple blouse and white pants, blue blouse and black pants, and blue blouse and white pants. A total of 6 possible outfits. Going back to the problem of Cassie earlier, the fast food restaurant offers a meal special of 199 pesos for a drink, a sandwich, and a dessert. The choices are, for drinks, we have soda, fruit juice, and chocolate shake. For sandwich, we have grilled chicken, cheese and ham, and fish fillet. For dessert, we have chocolate chip cookie or banana muffin. And the question is, how many meal combos or meal combinations are possible to order? Let us use the tree diagram. There are 3 choices for the first category, which is the drink. Then these choices will be paired to the choices of our second category, the sandwich. And lastly, the results will be paired to the choices of our third and last category, the dessert. By constructing a tree diagram, we can establish the total number of possible outcomes, which is equal to 18 meal combinations. This method, however, might be time-consuming. In situations where we are obliged to count large and vast quantities of numbers, several of the preceding counting approaches are ineffective. That is, when our mathematicians devised a method for calculating huge numbers quickly and accurately using a basic counting principle. The fundamental counting principle is one of the most essential rules in mathematics, especially in probability problems, and it is used to calculate the number of possible outcomes from a set of events. Using this idea, we will be able to take the same information and calculate the total outcomes using a simple calculation. The principle states that if there are number of outcomes in event A and number of outcomes in event B, then there are number of outcomes from A times the number of outcomes from B in event A and event B combined. Going back to the problem, we have 3 different categories or events. For the categories, we have drink, sandwich, and dessert. The number of choices for a drink is 3. For sandwich, we have 3. And for a dessert, we have 2. Using the fundamental counting principle, we have the number of outcomes for drink times the number of outcomes for sandwich times the number of outcomes for dessert equals the total number of meal combos. We have 3 times 3 times 2 or a total of 18 meal combinations. The fundamental counting principle is a mathematical rule that allows you to find the number of ways that a combination of events can occur. This multiplication method works if you have numerous factors like color, shape, and design that can be combined in any way. When you have a set of categories and one of multiple options in each category, you can utilize the method. Let us have some examples of situations in real-life scenario where we can apply the fundamental counting principle. The coronavirus has continuously seemed to have a significant impact on almost everyone, but students have been incredibly affected. Many schools and colleges suspended all classes of the school year or semester when COVID-19 struck. Others quickly transitioned to distance learning, requiring students to log in via online video sessions. Of all, school is about more than simply studying. Social experiences of the students have also been seriously affected. The virus makes no distinction between students' ages when it comes to interrupting their lives. Every student has been influenced in some way. Educators can develop or change their plans for the next school year or semester by surveying students and their parents. Your teacher is asking you to fill out a survey about the challenging aspects of online learning during the new normal with a 10 yes or no questions. In how many ways can you write yes or no to complete the survey? There are 10 stages or categories in the problem. These are the questions from 1 to 10. There are 2 choices for each question, yes or no. Therefore, using 2 as a factor of 10 times, the total number of possible ways to answer the survey is 1,024 ways. How about if you have an option to leave a question unanswered or leave it as blank? In how many possible ways can you complete the survey? We still have the same number of categories, but a different number of options. Since you have an option to leave a question unanswered, there will be 3 choices now. Write a yes, or a no, or just leave the item blank. So by using the counting principle, there will be 59,049 ways to answer a survey with that condition. COVID-19 has altered many of our everyday activities in unexpected ways. To limit our exposure, many of us are staying at home. Isolation and being at home might make us crave for high-sodium snacks, junk foods, and low-quality meals that provide immediate fulfillment for our taste buds, rather than nutrient-dense whole foods that can also be enjoyable. In these days of social isolation and self-isolation, this has been a challenging task for many. If you have not been directly affected by COVID-19 or have not tested positive, it has undoubtedly had a significant impact on your daily routine, which may have a bad effect on your overall health. It is necessary to practice self-control and prevent emotional eating because of stress associated to the COVID-19 pandemic and how it affects our life. In relation to the given scenario, a group of volunteers is planning a project called Free Meal for Anyone. They aim to provide free but nutritious meals to individuals who have been left most vulnerable by the pandemic, those who do not have the option of staying at home and being safe, and whose meals are based on how much money they make on the same day, if any at all. The free meal includes a soup, a dish, a drink, and a dessert. This means a person can only take one kind of soup, dish, drink, and dessert. For soup, they can have mushroom soup or chicken corn soup. For dish, the choices are chicken tinola, ginisang ampalaya, sinigang na bangus, and ensaladang talong. For drink, they have buko juice or lemon juice. And for dessert, they can choose from mango, pineapple, and banana. The question is, how many different healthy meal combinations are possible? There are 4 categories in the problem. These are soup, dish, drink, and dessert. The choices for each category are, for soup, we have 2, for dish, we have 4, for drink, we have 2, and for dessert, we have 3. Hence, by using the fundamental counting principle, we will multiply the number of choices from each category. So we have 2 times 4 times 2 times 3, which is equal to 48 different healthy meal combinations. COVID-19 pandemic precautions transformed how we get food, whether it is from restaurants or from our own kitchens. In terms of groceries, as consumers become increasingly accustomed to house delivery, this move also reflects a shift of thinking in the future. The new normal moves grocery shopping from one where you can feel, handle, and judge the quality of things to one where the value is appraised for you for those fortunate enough to have the resources to access these services. Another strange consequence of the pandemic on the supermarket industry is the growth of brands that bypass the shop entirely and sell directly to the consumers. Brands may obtain insight into the thinking of the buyer and communicate with them directly by using their own website and delivery. But have you tried unlocking a code like PIN codes, lock codes, and others? Have you thought on how many distinct barcodes are produced in every product in a grocery? A certain online store that sells essential goods wants to use a unique code for each product. The code consists of 2 numbers and 3 letters. What is the maximum number of distinct codes that can be used? There are 5 categories: digit numbers 1 and 2, and letters 1 to 3. There are 10 possible numbers 0 to 9, and there are 26 possible letters A to Z. Based on the problem, there is no restriction specified. Then it means repetition in the choices is allowed. Hence, multiplying them by the fundamental counting principle, we have 10 times 10 times 26 times 26 times 26, which is equal to 1,757,600 possible distinct codes that can be used by the online store for their products. Millions of individuals were confined to their houses to contain the virus, unable to work or continuing virtually. These not include personnel classified as essential, who stayed on the front lines of the outbreak. This group include workers in the health and care sector, victim support services, education, supermarkets, pharmacies, and banks. Despite the difficulties and hazards to their health, millions of frontline workers continue to work during the COVID-19 pandemic. These unsung heroes keep people nourished, pick up their trash, provide life-saving medicine, carry their groceries and packages, prepare their meals, clean their hospitals, care for the most vulnerable, and keep us safe, all while earning low wages and receiving little benefits. Showcasing artworks like the Great Mask has been trending since the COVID-19 pandemic arises, since students, especially those people below 18 years old, are not allowed to go out. As part of this, the Valenzuela city government aims to raise awareness and showcase the efforts of COVID-19 volunteers and frontline workers by hosting an e-poster making contest that will demonstrate the public's gratitude for volunteerism. The elimination phase saw a total of 30 participants from various barangays of the city. The champion, first runner-up, second runner-up, and third runner-up winners of the contest will each receive cash prize. In how many ways can the participants be awarded? There are 4 places or categories in the contest: the champion, first runner-up, second runner-up, and third runner-up. There are 30 participants in the contest. Since a person cannot be awarded in more than one place, the choices for each place will decrease. So using the counting principle, 30 times 29 times 28 times 27, hence there are 657,720 ways the participants can be awarded. COVID-19 is mostly transmitted from person to person by respiratory droplets. When you cough, sneeze, talk, shout, or sing, respiratory droplets enter the air. People who are close to you may breathe in these droplets or they may land in their mouths or noses. Masks are simple barriers to keep your respiratory droplets from getting into the hands of others. When worn across the nose and mouth, studies show that masks minimize droplet spray. N95 respirators and surgical masks are examples of personal protective equipment that are used to protect the wearer from airborne particles and from liquid contaminating the face. It is important to recognize that the optimal way to prevent airborne transmission is to use a combination of interventions from across the hierarchy of controls, not just PPE alone. In a company that produces N95 respirators and surgical masks, employees are required to wear their ID cards which have 5-digit numbers. The questions are the following. Number 1, how many ID cards can be formed if repetition of the digit is allowed? Number 2, how many ID cards can be formed if repetition of the digit is not allowed? For the first question, how many ID cards can be formed if repetition of the digit is allowed? Any of the 5 digits of the number to be formed can be any of the 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Hence, there are 10 choices for each digit of the number to be formed since repetition of the digits from 0 to 9 is allowed. When repetition is allowed, we have 10 times 10 times 10 times 10 times 10, or a total of 100,000 ID cards. For question number 2, how many ID cards can be formed if repetition of the digit is not allowed? We still have the same 5 categories, digits 1 to 5. The first digit of the number to be formed can be any of the 10 digits, hence 10 choices. The second digit can be any of the 10 digits except the digit used in position 1 since no repetition of the digits is allowed, hence 9 choices. The third digit can be any of the 10 digits except the 2 already used in digit 1 and digit 2 since repetition is not allowed, hence the 8 choices, and will be the same with the fourth and fifth digits. Therefore, multiplying the numbers of choices for each category, 10 times 9 times 8 times 7 times 6, the total will be 30,240 ID cards. 911 is a well-known hotline that is used by several countries to act and respond to emergency cases. In the Philippines, we also use hotlines. In relation to this, hotlines are one of the most widely used methods by health officials in the COVID-19 pandemic response. They create a direct line of communication between at-risk groups and emergency responders. It also serves to increase responders' awareness of the perspective of the people, their attitudes and worries, and provide public health advice, counseling, and/or referral to other resources. The Department of Health and the World Health Organization are working together to raise public awareness about the importance of public mental health, particularly in the wake of the pandemic. Many people have been dealing with major mental health issues in recent months. COVID-19 has resulted in increased feelings of helplessness, isolation, grief, anxiety, and depression in addition to the disease health effects. It has also resulted in self and social isolation, disconnection from family and friends, quarantine, and movement restrictions, resulting in more people than ever experiencing feelings of helplessness, isolation, grief, anxiety, and depression. As a result, the need for health support services has increased. In response to the continuing increase of cases, a telecommunications company intends to establish up a hotline number that will be available 24/7 for immediate assistance regarding mental health concerns. It is composed of 7 digits. The first digit is 5 and the last 6 digits cannot start with 0. How many different phone numbers are there for a specific hotline? There are 7 categories. The first to 7th digit of the hotline number. The first digit is 5, no other choice, which is in fact one choice only. The first digit of the last 6 digits or the second digit can be any digit except 0, so 9 choices. And since there is no restriction specified, it means choices can be repeated. The third, fourth, fifth, sixth, and seventh digits of the number can be any digit. Hence, each has 10 choices. Using the counting principle, the total number of possible phone numbers for the specific hotline is given by 1 times 9 times 10 times 10 times 10 times 10 times 10, or 900,000 different phone numbers. Cassie already chosen one from the 18 combo meals or meal combinations we obtained earlier. This became possible because of your great work. Good job, students! Moreover, the restaurant offers a free coupon for a 50% discount if Cassie can answer some problems involving counting the number of occurrences of an outcome in an experiment. Will you help Cassie again to get the discount coupon? That is awesome! Our next activity is entitled Count for the Coupon. We need to solve the following problems by determining or counting the total possible outcomes. Choose the correct answer that corresponds to the correct letter or number that will complete the code for the 50% discount coupon. Use the react buttons heart or like, and you will be given 10 seconds to determine the correct answer. Are you ready? For problem number 1, a basketball series of 6 games is played by a school. A win, a draw, or a defeat are the 3 options for each game. What is the maximum number of possible outcomes for the series? Is it heart, 216 outcomes, or like, 729 outcomes? Timer starts now. If you answered like, then you are correct. There are 6 categories. These are the 6 matches. For every match, there are 3 possible results: win, draw, or loss. Hence, there are 729 possible results for the series. This gives us a letter M. For problem number 2, a 4-digit personal identification number or PIN ranging from 0 to 9 is required for a debit card. It is also possible that the digits will be repeated. What is the maximum number of potential pins? Choose heart, 10,000 pins, or like, 5,240 pins. 10 seconds to answer, go! That is right. The correct reaction is heart. There are 4 categories: first digit, second digit, third digit, and fourth digit. Since the digits may be repeated, there are 10 options for each digit of pin. Therefore, there are 10,000 possible pins. Now, we have our second letter S. Let us continue. For problem number 3, Amy wants to borrow 3 books from the library, 1 each from the history, science, and fantasy sections. There are 35 distinct historical books, 80 distinct fantasy novels, and 50 distinct science books in the library. How many different book combinations does Amy have to choose from? Click heart for 140,000 combinations or like for 150,000 combinations. 10 seconds, go! If you hit heart, then you are correct. There are 3 types of books: history book, science book, and fantasy book. The number of choices for each type: 35 books for history, 50 books for science, and 80 books for fantasy novels. So the total number of combination of books is 35 times 50 times 80, which is equal to 140,000 combinations. With this, we have number 1. For problem number 4, you are going on a road trip with 4 friends in a car that fits 5 people. In how many ways can everyone sit if you have to drive the whole way? Click heart for 120 ways and like for 24 ways. You have 10 seconds to answer. Go! If you answered 24 ways, you are awesome. The fundamental counting principle is a great way of thinking about this problem. You must sit in the driver's seat. There are 4 options for the first passenger seat. Once the person is seated, there are 3 options for the next passenger seat. This goes on until there is 1 person left with 1 seat. Therefore, there are 24 seating arrangements in this problem. Our next number is 3. Next is problem number 5. A race between 12 students is held. How many ways will the first 3 awards be awarded? Choose heart for 1,728 times or choose like for 1,320 times. Timer starts now. There are 3 categories because of the 3 prizes. First, second, and third prizes. The number of choices for the first prize is 12 students. Since a student already got the first prize, the choices for the second prize will decrease by 1, which is 11. Same with third prize, 2 students already got the first and second prizes. The number of choices for the third prize is 10. Hence, 12 times 11 times 10 is equal to 1,320 times. You are doing well, students. We now have 1 as the 5th character for our code. And for the last problem, you have a pair well-shuffled deck of 52 cards. It consists of 4 suits. The suits are clubs, diamonds, hearts, and spades. There are 13 cards in each suit, consisting of 1, 2, 3, 4, 5, 6, 7, 8, 9, Jack, Queen, King of that suit. Suppose you need to draw 2 cards from the deck. How many possible ways can you draw the 2 cards? React heart for 2,652 ways or like for 2,704 ways. 10 seconds, go. If you chose heart, then you are right. There are 52 ways to draw the first card. There are 51 ways to draw the second card. Therefore, 52 times 51 is equal to 2,652 ways to draw the 2 cards. The last character for the code is 5. The code for the 50% discount coupon is MS1315. Thanks to your effort, Cassie can use the discount coupon for having a meal in her favorite fast food restaurant. A job well done, students! To sum up today's lesson, here are some points to remember. A random experiment is an experiment, trial, or observation that can be repeated numerous times under the same conditions. The outcome of an individual random experiment must be independent and identically distributed. It must in no way be affected by any previous outcome and cannot be predicted with certainty. We could determine the number of occurrences in an experiment by systematic listing, table, tree diagram, and fundamental counting principle. The fundamental counting principle states that if there are number of outcomes in event A and number of outcomes in event B, then there are n of A times n of B outcomes in event A and event B combined. We will now proceed with a question and answer. A question from a student of Polo National High School: what is the best method in counting the total possible outcomes of an experiment? The answer is, the best method will be a combination of the methods earlier, namely tree diagram, systematic listing, table, and FCP. Some of them can only be effective in certain cases, so it is better to use the combination of methods in counting the total possible outcomes of an experiment. Another question is, what is a pair coin? A fair coin is an idealized randomizing device with two states, usually named as heads and tails, which are equally likely to occur. And for your home learning task, answer what's more and what I can do on pages 24 and 25. I hope you have learned a lot about our topic for today. And remember, according to someone anonymous, don't just count your blessings, but also be a blessing other people count on. This is Miss Sarah Jane B. Jimenez. Good day, stay safe, and God bless.